right. So great to see everyone. Many familiar faces, although I know some of you just met each other. Hopefully we'll get much more acquainted over the course of this panel. I think many of our guests here don't need much intro, but we'll still do a quick one, maybe like a 30-second intro for each of us. Maybe Anurag, would you like to start?
Sure. Hi, my name is Anurag. I'm a co-founder of Avail. Avail is a new L1. So Avail is a new L1 that focuses primarily on providing data availability primarily for rollups. It's basically a unique implementation of data availability sampling. Similar to Celestia, but they use fraud proof for implementing DS, and we use a validity proof technique in KZG polynomial commitment. So that's the basic context. Prior to this, I co-founded Polygon, and Avail is actually a project that was started within Polygon, but we spun it out in earlier this year.
Hey, I'm David Shea. Nice to meet everybody. So I'm a guy who's obsessed about Bitcoin security. I don't know why, but every day I wake up, I think about it. And then a year and a half ago, I decided to start a project, bringing Bitcoin security to the rest of the decentralized world. And here I am, working day and night on Bitcoin security. So newest protocol, Bitcoin staking. Super excited about it. I have a side job. My side job, don't tell people though. My side job is a professor at Stanford University. And in fact, at Stanford, we have a research lab on consensus protocol. And one of the things we did was we helped Ethereum fix their proof of stake protocol when they launch. But a small secret, it's not completely fixed yet.
Hey guys, I'm Nick White. I'm the COO at Celestia Labs, and we're building Celestia, which is the first modular blockchain network. And specifically, the Celestia focuses on the consensus and data availability layers of the modular stack, which is the foundation of security and scalability for like the modular blockchain ecosystem.
Hi everybody, I'm Sriram, founder of EigenLayer. EigenLayer is a mechanism that lets anybody borrow the decentralized trust of Ethereum to build arbitrary new things. So one way to think about it is Ethereum created this idea that anybody can build an application on top of a common network. And what we do is make it much more programmable. You can build arbitrary distributed systems. You have any idea for how to build an Oracle machine learning network, data storage network, data availability, bridge, SQL, whatever you have, you can go and borrow the trust of Ethereum, the Ethereum staking and the validator network to build whatever new things you want. So that's EigenLayer. I just want to add to David's thing. He's obsessed about Bitcoin. Yes, we wrote a paper together 4 years back, and it was about analyzing various consensus protocols. And David came up with the name. It was called Everything is a Race, and Nakamoto always wins. He's trying to make Nakamoto win, so we'll see about that.
Awesome, thank you guys. Now, we've brought everyone here together under the umbrella of modular layers. Although here, I think we have slightly different flavors, right? Are we talking about the modular stack, modular blockchains? Are we talking about unbundling aspects of a blockchain, or also adding functionality to it, be it borrowing security, adding new apps by extending what can be used with the cryptoeconomic security of various chains? So, would you like to share what your take on modularity, the case for it, and whether this is a new thing or not, right? What kind of mindset shift are we trying to bring about here? Please feel free to start anywhere, and please make it conversational. Let's bounce off each other. Maybe start with Shriram this time.
Yeah. Modularity, in our view, is whenever markets mature, the boundaries of various layers become clearer, right? So this is, whenever you're building the first motorcycle, you're not thinking about somebody is manufacturing the tires, somebody else is going to manufacture the engine and so on. You do everything together. Once markets mature, you figure out where the boundaries are of various things so that people can specialize and build these things. But something's unique about blockchains or crypto. You say something's a crypto solution only if it's built on decentralized trust. So when you want to think about modules, the thing that I think about the most is if each module is building on its own random security, and you have to get a end user product, you have to couple together many modules, you get the worst of the security of all the modules that you're using. So this is what led us to EigenLayer, which is the idea that there's a common security pool that supplies trust to all these modules. And our vision of what the modules are is actually much broader than what many other people are thinking about. You know, when people are thinking about a modular stack, they think about consensus, data availability, you know, execution, this kind of thing. But the way we think about it is look at the internet. If you look at the internet and see how web application development works, you have, you know, if back in 95, if you're building an application, you're building your own server stack, you're building payments, you're building your own authorization, you're building your own database, all of these things. Today, if you're building a web application, you go to AWS, there is 1,000 SaaS services, software as a service kind of solutions, each of which doing each of these things at a highly specialized, granular manner. When you're building an end application, you just concatenate a Stripe and OAuth and MongoDB and all these things, and then you get your end solution. That's the world we envision for crypto. There are thousands of modules that are being built, oracles, you know, secure multi-party computation, secret sharing, all kinds of interesting things. And then you concatenate all of these things and then get an end user solution. And they're all on common security. In our vision, Ethereum security. So that's the EigenLayer vision of modularity.
I'll jump in. I think Shriram started with a really good analogy, which is that you start building. If you build a first motorcycle, you don't think about all like the components, right, that go into it. But perhaps as you build more and more of them, you start to have an insight about, oh, okay, this is like one natural piece that's separate in functionality from the rest of the motorcycle, and I can kind of like design and optimize that piece. Oh, here's another piece. Here's how they can fit together. I think the same thing is what's happening in blockchain today, where originally, Satoshi designed Bitcoin, and it was a monolithic protocol, but it succeeded in its purpose of building a decentralized application. But then as time went on and people started to understand blockchains better, it became clear that there were actually sub-components or sub-functions within each blockchain that didn't need to be coupled together, and we could decouple them, build specialized protocols to solve those problems, and then connect those protocols to, again, build applications, but with like significant benefits like scalability and more flexibility. And I think it's like Shriram said, it's a reflection of the maturity of the technology and our understanding of what we're actually doing that modularity is emerging. And I think we're very far from done. I think there's still not only a lot of experimentation to be done at each layer of the stack, whether it's data availability, consensus, or execution, but there's also new emerging layers like shared sequencing, or even people wanting to build shared prover networks or co-processors, or like I think that we're going to continue to expand, kind of like what Shriram said, the scope of what different modules are possible and useful. So I'm excited for like the next 10 years. This is like 10 years ago, or actually more than that Bitcoin was launched, and the next 10 years of the modular space will be really exciting to see what new technology gets built and explored.
Yeah, so I would like to comment a little bit of a different angle, which is associated with this, whether or not modularity gives you new properties or new features, or it's just a matter of factorizing existing feature. So I'm more of the lines of new features. I'll give you an example. So Ethereum 2.0 is a very complicated protocol. It's one of the most complicated protocol ever. And you can ask, well, why is it so complicated? Why does it take like 7 years and 8 years to design? Okay, they design a motorcycle because they want many, many features in this motorcycle. But however, if you think about it from a modular point of view, then you can break down these features that they want. And you can design different modular parts of the consensus protocol to achieve these features. For example, they have this thing called a finality gadget. And then they have this thing called LMD Ghost. And the names get longer and longer as the protocol becomes more and more complicated. Why is there such a complicated protocol? It's because they want to achieve a feature of finality, but at the same time, they want the chain to dynamically keep on growing no matter what. So these two are actually quite opposing features, but they want both. And only after thinking about this whole thing from a modular point of view, then you realize that actually it's better to modularize this protocol into two parts, and each part satisfying each of the individual feature. So if they had start from that, it won't take them 7 years, and it won't still be a protocol that needs improvement. In fact, Shriram and I, each of us wrote a separate paper addressing this same topic. So I think that's a good example of designing protocols from a feature point of view. You start with a feature, and then you break down the motorcycle into different parts to optimize for the different feature.
Yeah, I think the rest of them covered a lot of points, but I just want to kind of take the opportunity to, so there's been discourse around modular systems and, monolithic system. People have been trying to rename monolithic blockchains as integrated, right? So I'll just take the motorcycle example here again. And so basically, whether you build a motorcycle in a factory altogether, or you kind of make these wheels in a separate factory, or basically make modules independently, the motorcycle still runs, right? In fact, if you kind of break down your supply chain into well optimized parts and then build them together as a motorcycle, the motorcycle is much more cheaper, much more efficient, and so on, right? So there's no benefit to keeping a system monolithic or everything is integrated. Modular systems are also integrated in that sense, right? So there's no difference really. The truth is, initially, the analogy is actually pretty great, that when you start out building new systems, they start out a certain way, and then when they mature, you have to start optimizing because you see the obvious benefits in modularizing, right? Manufacturing those components separately, right? So that's basically the modularity movement. Now, there are various aspects to this, modular is a very catch-all term. So I don't want to focus on that term in specific, but some projects are taking Babylon is trying to capitalize on Bitcoin security. Eigen is trying to capitalize on Ethereum security. But in general, I think one point I just want to emphasize is, right now, the last 2-3 years, we have seen a lot of rise in cryptographic security, relative to crypto economic security, right? A lot of ZK validity proof driven systems have kind of matured pretty significantly, pretty fast. And so the whole basis around how we view leveraging security is also changing, right? Initially it was, how do we leverage this cryptographic security of a particular system? But now in these newer ZK or validity proof driven systems, if you have cryptographic security, let's say state verification guarantees, like safety guarantees, then what is the role of other systems, right? What is the role of Ethereum, for example, right? Is really Ethereum responsible for state verification now, or is the state verification component just a bridge component? So there are these various things, of course, the order of transactions, for example, again, I'm getting a little bit into the weeds of blockchain modules, but so the whole dialogue around what a blockchain system should look like in the future, that is constantly evolving, and specifically due to validity proven systems, due to cryptographic security, a lot of the assumptions have changed, and so we now see a lot of opportunity, not just in, let's say, leveraging Ethereum security, like what Eigenlayer is doing or Babylon is doing in terms of Bitcoin, but let's say at Avail, for example, we are focused on this new kind of layer where we let's say, because the most thing what we are more excited about is this whole roll-up or off-chain execution thing, right? It's not only roll-ups; it can be a lot of other things, right? But how can we do shared security, right? Some people do it on Ethereum, some do it on Bitcoin. We try to do it on Avail. So everything is an experiment, right? We are pretty early. So yeah, long-winded answer, but that's my take.
Yeah, great. Well, Anurag, since you've brought it up, let's go there, right? Around kind of cryptographic versus crypto economic security. And I would love to, I don't know whether this is related, I'm sure you get there as well. How does it also relate to sovereignty of systems, right? Because kind of going back to the motorbike example, where you have supply chains, now supply chains are also getting somewhat fragmented. And also, should you own the whole supply chain and control it? Or should you let third parties, and you have like contractual agreements that you have some sort of trust that it will be executed by that nation state, right? Which sometimes can come at odds with each other. Yep.
So the way so I mean, again, there's this some discourse around like modular systems being like disconnected and like not integrated and so on, right? Like, I mean, see, if you as a user, for example, if you're using something like Arbitrum or like anything like that, right? Like, I mean, you don't really see much difference in your, I mean, of course, if you get into the weeds, there is a finality delay, for example, and so on. But like, there's no real difference between a user transacting on, let's say, a Solana versus someone transacting on Arbitrum 1, right? Like, in fact, Arbitrum 1 has maybe millisecond block times or something like that, right? Like, so, I mean, essentially, there are, of course, nuances around let's say modular layers being disconnected and such, but in general, I think it's all a maturity issue, right? Like, I mean, this is just still pretty new, and the right abstractions are still being in development. So I think things will improve pretty fast, is what my take is.
If I may just somewhat pit this against each other. So we have slightly different approaches here, right? Because Anurag, I know you're going for more of the validity and cryptographic approach, whereas we have a couple of different crypto economic approaches, right? Be it borrowing security from Ethereum or Bitcoin, or in Celestia's case, kind of having its own set of validators and for security. So why did you guys make these decisions? So what are the considerations here, and therefore the design like trade-offs and optimizations as a result of these choices?
Can I say a few words about this? So I feel that there may be a little bit of confusion. Just want to clarify, at least for myself. So in my mind, right? So in a system like Bitcoin, okay, there are two aspects of Bitcoin. One is that you want to figure out what is the ledger, okay, and that's the role of the longest chain protocol. Second, you want to figure out whether the ledger consists of valid transactions. That's the job of the miners, in the case of Bitcoin, verifying the transaction, okay? So I think, so there are two aspects to this, right? One is the validity, and one is the ledger. The validity is, I think, what you talk about, is cryptographically, like ZK proofs, etc. So that's the cryptographic aspect. But the ledger is determined, must be determined by the validators or the miners of the protocol, because there is no absolute truth. You could have a fork, and you could have two ledger and two forks, both of which are valid, but we don't know which one is the truth. And so therefore the truth can be only defined by the miners that do the majority work. And I think this crypto economic security that we're talking about is essentially making sure that, hey, if you try to fork the system, then you have to pay a price. The price will be huge. So I just want to clarify that point. Hey, sorry, I sound like a professor. I don't know why. I'm sorry. This is like
his part-time job's coming out.
just to clarify that.
Yeah, I want to add a little bit to this whole thing. What can be cryptographically certified is correctness of a sequence of statements. Right? That's really all that cryptography can certify. There are a lot of things that cryptography cannot certify. And sometimes even crypto economics cannot certify. So I want to give you a lot of examples like that. One example is reorgs. David mentioned forking, right? If a chain reorgs, how can I prove to you that I have not created another chain with equal validity? You don't know. So reorgs is only crypto economically. So you can identify that somebody reorged the chain and then go and penalize them. Okay. Then you go to some other kinds of faults, which are not even clear that you can do crypto economic penalties, like censorship resistance. How do you know that the validators, included all transactions that were sent to the validators? Is it observable to you? Like, do you know what got sent on the peer-to-peer network? It's not easy, very difficult. And then maybe if you're always snooping around on the P2P network and you know that something went around, you can penalize. But the question is, who are you and how does this guy know and how do we know that guy is right? All of these problems. So there's a kind of relativity issue there. Okay, then you go to some other kinds of faults, which are not even observable to anybody else. Imagine I take a secret and then I split it into n components and then send it to a network. Okay, and the network is not supposed to reveal the secret to anybody, and no one has access to the secret. Now, they all meet in a private room and then they expose the secret. How do I know that the secret has been exposed or not? How do you penalize this? So I think the notion of what is trust and security goes far beyond what cryptography can certify, and even cryptoeconomics can certify. So I think we need a lot more clarity in these discussions. But the question was, why are we building the particular kind of architecture we're building? And my answer to that is, we look at the Ethereum protocol today, and they've taken this massive bet on rollups and layer 2s. And when you look at it, there are lots of, while it looks really promising, there are lots of gaps in the rollup ecosystem. Data availability being one, there are 3 projects here which are working on that, including ourselves. We have a data availability protocol called EigenDA, Eigen Data Availability. But the reason we chose to work on Ethereum and shared security from Ethereum is Ethereum's already in the shared security roadmap through the rollups. We're just expanding it. For example, Anurag mentioned this idea of Arbitrum having fast finality. It's really addictive. Like you just go and you click and then you get final, right? It's pretty amazing. But it's not real finality because it's not going into the chain. But with EigenLayer, you can start getting much sharper assurances. You run a sequencer sends the block to like a large group of nodes which are putting up a lot of stake. And then you can get a soft confirmation. But this time the soft confirmation comes with $5 billion of security. If the soft confirmation is broken, $5 billion will be slashed. So you can actually take these experiences that rollups are providing today and then add a weight that you cannot get. And why cryptoeconomic? Because you have to wait for 12 minutes for a block to get finalized on Ethereum. But I can give you a finality certificate in 1 second by running the latest and greatest consensus protocol. We can do latency transformations. We can do all kinds of interesting stuff. How to move data across different rollups. I can restake and then make credible commitments on them. So there's all kinds of things that are complementary to the Ethereum modular landscape. And because rollups are branded on Ethereum security, it's better to just borrow Ethereum security. So that's our vision on that.
So I really like that David made his clarification at the beginning, because that's something that a lot of people don't understand about blockchains, or they get wrong. People think that it's the validators or the miners' jobs to secure and ensure the validity of the chain, but it's actually separate. So like they are meant to provide consensus, which is guarantee the ordering of the canonical chain. Now they can always cheat if they want to, but the point is that you have stake that makes it so it's expensive if they try to reorg or fork the chain. However, so that's the consensus part. But the validity of the chain, the validity of the transactions, you should not rely on the miners to tell you that the chain is valid. You should verify the chain directly yourself. Because if you trust the miners, the validators, they could lie to you. And if they lie to you, so this is also really important. A reorg or a fork, the worst thing you can do is a double spend. And a double spend has a very limited downside in the sense of you can only double spend funds that you have access to yourself, and that you can somehow get value off chain. So for bridges, you could double spend on a bridge, for example, or you could send it to an exchange and sell it for USD and withdraw the USD. But that is a significantly less bad attack than if you straight up break the rules of the chain and just steal everyone's funds, put it into your address, or what have you. So there's a huge delta between these levels of attacks, and that's why it's so important that in blockchains you don't trust validators, you verify the chain directly. And so kind of now taking a step back to modular layers, at Celestia we really believe that you want to inherit the consensus and also the ability to verify from the base layer, whether that's Ethereum or Celestia or something like Avail. And you do that by, it's like well known now how you do that. You post the data of your chain, of your rollup, to that underlying layer where it is ordered by that same committee, whatever the validator set of Ethereum is or validator set of Celestia is, and you can verify the data availability by running a node of that chain. And that gives you both so you inherit both the verifiability and the consensus guarantees of the underlying chain. And I think now there are limits to the kinds of systems you can build in that. Like it has to be a rollup, has to be something that is verifiable cryptographically, which I think is a broad range of things. But there are certain things like oracles, or I don't know, other committees I'm sure Sriram talks about, where you do need to make a committee-based assumption. You need to trust a set of people, and I think in that case, like using like a restaked asset, right? If you're restaking Ethereum, you're actually like that's just the underlying collateral asset, but you're not actually necessarily inheriting the consensus guarantees of Ethereum-based chain. You're spinning up a net new committee that shares the underlying collateral, but not necessarily the same security of Ethereum. At least that's the way that I see it. But so they're very different tools, and I think it's really useful to be able to spin up new committees with a liquid, valuable asset like Ethereum or Bitcoin. But they're just different approaches and have different like benefits essentially.
Yeah, just to quickly add, right? Like I mean, so of course, like David really rightly pointed out, right? That there's this cryptoeconomic element and the cryptographic security element. The folk choice rule, or like whatever you want to call it, right? Like, so just want to point out, right? Like so all these projects are doing kind of the same thing, like kind of the same goals, but with different tools, right? Like, just to point out, like one small point from what Sriram said, like you mentioned, like $5 billion finality, right? Like Ethereum restaking doesn't mean that you inherit the entirety of Ethereum stake. That's a very important distinction to make. Like you leverage some of Ethereum security, like an opt-in set of validators who kind of opt into this service of running, let's say, EigenDA or some other node, right? Like so, Ethereum restaking specifically doesn't mean borrowing the entirety of Ethereum security. It is again a separate cryptoeconomic mechanism, which also needs to have its own incentives, which is again, it's again a different problem, right? Like it's not like, like it's very easy to kind of get Ethereum stakers to run, let's say, EigenDA nodes, for example. I mean, not kind of don't mind what I'm saying. I'm just stating out the facts. Like essentially, so for every project, right? Like there are two broad phases, right? Like there is a novelty phase, and then there is a commoditization phase. I mean, I've gone through one cycle of this. I started as a like a plasma scaling solution back in 2017. That time plasma was the rage. Then rollups were the rage, for example, right? Like, and so everything starts out with a novelty component and then eventually commoditizes. ZK EVMs were the rage maybe 1 year, 2 years ago. Now, like Polygon has released a chain development kit where, like everyone can roll up a ZK EVM chain. Yeah. I mean, so what I'm trying to say is, in the long term, everything has to be sustainable. Now, are you building a system which has the tools to ensure sustainability in terms of yield for its participants, incentives, etc.? So those are the trade-offs every project will take, right? I mean, and that stands true for every project in this lineup, right? Like everyone has to think about, how do I get past, how is my project sustainable after the novelty phase?
Sure, I can say something. It's really in thinking about sustainability we came up with EigenLayer. Shared security is more sustainable than individual security. Individual security can undergo death spirals. So imagine I'm running a chain. This chain has some amount of security. And based on this security, I get a bunch of use cases. Now, for whatever reason, some bear market hit and the chain token went down 10x. Now, users are worried that their system's not that secure because economic security took a death spiral. And that crashes the token further. And token goes down further, the security goes down further. So this is the problem we see with disaggregated security. Not to say any of us here are building disaggregated security, right? Avail is a chain, so there are many use cases going to be building on top of it. So it's possible to be sustainable on that basis. But the fundamentals is that the more you aggregate, the more disparate demand that you aggregate, the more you're immune to these kind of death runs, because ETH, is less volatile than any dApp token that can be built on top. That's just a fact, right? And therefore, when you're acquiring these security, you're only paying the marginal cost. Each protocol, one way to think about aggregated security is, let's say there are 1,000 protocols, each of which can sustain $1 million of staking. That's the sustainable yield. Instead, you aggregate all of this and build a $1 billion staking, which is shared by 1,000 protocols. It's better for everybody. It's better for everybody to be in this aggregated pool. It's like stronger together, right? Why do we have, each city doesn't have an army. Only the United States of America has, or even NATO has, an army. Why is this? It's because when you aggregate, you're able to provide security services better. You don't need to provide services for each application separately. So that's actually a shared story for all of us. That's really what a shared data availability layer is. That's what shared security is. But what is the base on which the security is being shared? I think there is differences in these different projects.
Yeah, maybe I can give an example as to sustainability, which is a little bit along the lines of Sriram. But so there's a Cosmos chain that we work closely with called Akash. So Akash is a app chain that basically is a platform, a decentralized cloud platform providing AI chip service. So their token is called AKT. When they launch this token, they have to inflate this token 100%. Now, if you inflate the US dollar by 100%, you would not call that sustainable, right? So obviously it's not sustainable. And why do they have to inflate 100%? Well, because they need to attract people to come and buy this very new token, very volatile token, in order to stake, provide enough security. So imagine, suppose you have now Bitcoin staking, right? Now you're using an asset which is much more volatile, less volatile, and potentially much cheaper cost because it's a much larger in supply. Instead of that, they can focus their token on actually incentivizing the application itself to have the best AI chips provided to this platform. So that seems like a much better, longer-term strategy for them. And in fact, the founder told me that, hey, if we had BTC staking, that would be the solution we go for. And in fact, now they're still working with them on sort of diversifying the portfolio to provide some BTC staking. So just an example of sustainability, I think.
Yeah, I think David brings up a really good example of what I think restaking is useful for is if you need to launch a new chain or protocol that requires some kind of collateral, it can be difficult to launch your own token and to bootstrap liquidity, distribute that token to enough people, and then convince people to stake it. And that's a real challenge for people who want to launch a new chain or some kind of other committee-based protocol. And so it's really, really useful when you have a already existing, well-distributed asset like Bitcoin or Ethereum with a lot of liquidity to do that, because it's a shortcut and removes a huge amount of overhead. However, I think it's really important to note that using Bitcoin or Ethereum as collateral does not mean that you share any security with the Ethereum network or the Bitcoin network, because those are separate protocols, and the miners that are running or validators running Ethereum or Bitcoin, or the people running nodes at home verifying Ethereum or Bitcoin, will not verify or secure your new chain. You're just sharing an underlying asset. So I think that's a really important thing that I think sometimes is misunderstood in the common discourse.
Yeah, so maybe I can make a quick comment on this, very short. So in the case of Bitcoin sharing security, actually we have sort of two solutions. So one is called timestamping. So timestamping is the full sharing of the fate of the entire Bitcoin network. So if you fork the proof of stake chain, you have to fork Bitcoin itself. However, that is slow. That's slow because Bitcoin is slow. And so what Bitcoin staking would do is to increase the fast economic security. So what one can do here is you can imagine that perhaps for less valuable transactions, you can just take the fast confirmation with lower security. And for very valuable transactions, you can wait for that. In the case of Bitcoin, maybe like an hour or half an hour of confirmation. So that could be one way of sort of leveraging off both the full network, which is slow, and the collateralization, which is less secure maybe because you don't get 500 billion Bitcoin. But yeah, so that's one.
Yeah, also quick point here, right? Like, I mean, it seems that, like on crypto, Twitter, and here, like, like all the modular projects are bickering against each other. But essentially, see, everyone is trying some sort of shared security kind of model, right? Like, I mean, the Cosmos example is pretty good, right? Like, there's a lot of Cosmos chains that will be dead pretty soon or are dead because the token value went down, so the security went down. So, I mean, ultimately, this, like where the modular term itself is not a very good representative, but essentially, like everyone in this panel is trying to do some sort of shared security. Now, where that security comes from, that's the specific implementation trade-off that each project is taking, essentially. But ultimately, the idea is that, like, don't bootstrap your own security. Use some system that, like has some security, or, and just reuse that or borrow that, some of it or all of it. So those are the kind of trade-offs. But essentially, the fight is against, like don't roll your own security kind of a thing.
Yeah, I would even say, the fight is not against roll your own security. The fight is about what set of things can we bring to the blockchain space, right? That's really what, if you think about the broader scope of our projects here, is essentially every digital platform, right? If you think of any digital platform, it could be, it could be a cloud service, it could be like Uber, it could be a social network, it could be the metaverse, it could be AI. All of these are digital services. And how do you induce these digital services to have and make credible commitments? So when you're running a service, how do you get a sense of assurance that the service will run in the specified way for a long period of time? I think bringing this is what our vision is to the crypto space, is bringing the notion of credible commitments which services can make and service runners can make. That, for example, people build on Twitter, right? Like many years back, this is 2014, Twitter switched off its API, right? Or made it very expensive. And so what happened was a lot of projects that built on Twitter just had to die. And instead, can you build a version of Twitter which is immutable open API system, where once you build it, I know as a developer, I'm standing on a robust platform, when I'm building on top of this API. I think that's really what the broader goal is for all these projects. And I think, that'll be the measure of our success, is to what extent have we brought credible commitments into the digital economy?
Awesome. All right. I feel that the conversation has gone. I love the bouncing around. I love to still pick up on one thread and continue it. When we talked about sustainability, the flip side of that is also growth, right? And incentives for that. I think as Anurag mentioned just now, as past a certain stage, we might expect multiple similar solutions to come about. And in crypto, we often see somewhat maybe adversarial players. You might have some sort of vampire attacks. Or even on your network, let's say you have some sort of incentive for using the shared security properly, but they could create some sort of like Ponzi to then farm in, and then that leads to warped incentives, right? Let's say they are willing to get Slash just because they can get some sort of Ponzi coin and sell that. How are we thinking about growing adoption? Is it going to be purely, organic and like outreach, or can we still bake in some sort of incentives, which is such a powerful element of what Web3 can achieve?
Yeah. So see, I think so. We worked a lot. I mean, I've worked with like thousands of developers at Polygon, and like the idea, like when like a lot of people talk about adoption, right? Like I mean, the thing is that it's still very hard to build like anything related to blockchain, right? Like an app, right? Like I mean, if you take something like the EVM today, right? Like so we had this integration with Starbucks, like with Polygon before, right? Like and like if you kind of think of, they wanted to add like an NFT to their app, right? Like that was the requirement, right? Like they had to write an indexer that indexed all the EVM blocks and like passed out their own logs. They had to write transaction relay infra because like you send a transaction, it doesn't get accepted, you have to retry. They have to like run subscribe to a hosted RPC service because running a full node is, I mean, you can't do it frankly today, right? Like I mean, so there are all these problems. Like when you are an app developer today on today's blockchains, right? Like you have to run all these additional infra to order, like to run something as simple as an NFT, right? Like I mean, and with this kind of tooling, you cannot expect mainstream developers to be like quickly churning out apps, right? Like I mean, you have to ensure that the development experience is easy enough that you have like a lot of developers trying out things, and over the course of time, like because there's a lot of crowdsourcing of creativity that is required, right? Like I mean, when the first mobile OS came out, right? Like it wasn't that like Uber got built in a day or a year, for example. Like something like Uber or Instagram took 5, 6, 7 years to be actually visualized because there's a lot of iterative development that you need to do to get to the realization that, oh, I can use, like a GPS coordinate to book a cab, for example, right? Like, so that's the same thing with blockchains, right? Like, I mean, there is a certain level of a set of primitives that have emerged, but these primitives have to be used, iterated, like easier to develop tools have to, I mean, so there's a lot of things that are still left. We haven't reached that point where developer tooling is such that we will get a lot of developers into the space. And right now also, like you said, incentives, so like, I mean, like it or not, there's a lot of, like airdrops and stuff like that that's happening in the space, right? Like, I mean, this is not the, like environment which will get adoption, right? Like we have to get past this. So there's a lot of time and, like we need, to make these development tools more mature. It's happening, right? Like it's not like things are not progressing, but I'm saying that we need to be like, we have to look at past technological revolutions and see these are all basics, right? Like I mean, so we have to focus on that, and thankfully, like there's a lot of developer tooling in investment happening. Capital is going into the space. There are good developers working on this problem, and so it's a case of infra plus tooling both, right? Like I mean. And frankly, I will say EVM chains are not going to be the dominant pattern. There are going to be a few chains which will be dominant EVM, but everything else has to be a little bit more DevX friendly, for example, right? Like I mean, so there's a lot of things that are coming, development, so on.
Very spicy take. We have 5 minutes left. So how else can we get adoption, developer adoption? How do we think about it?
Counter take again. I think Anurag mentioned the kind of problems of developer experience and infra being ready. I think there are fundamental problems in the space that we all kind of hide under the rug, and I'm going to kind of specify a few of them before we are ready for prime time. Number one, immutability versus upgradability. Imagine I'm writing a contract. This contract borrows decentralized trust only if it's immutable. To the extent it's immutable, I cannot innovate on top of it and find the product market fit that Anurag just talked about. If I make it upgradable, then the question is, who is responsible for the upgrade? Okay, so if it's like a 10, on EigenLayer, we have a 13 member multisig. I don't like this, right? I don't want, if it's a 13 member multisig, why not run a 13 member chain, right? But the problem is, this is at the heart of blockchain today. If you write a contract, if it's not immutable, it has to be upgradable. If it's upgradable, then somebody controls it. And this is a fundamental problem. We don't talk about it. Everybody, hides it under the rug, and it's a fundamental problem. Another problem, we have hacks, right? Your contract has bugs. This is the harshest deployment environment ever created for software. It's open source. I'm going to give you all my code as an attacker. It's open state. I'm going to tell you what I'm doing right now so you know when I'm at the weakest moment and come and screw me. It is open entry because, censorship resistance. We like to let attackers in even if we know they're attackers. And open exit. Immutability means once you come and attack and take my money, you are out free. Okay, all of these are values. None of these are dispensable. Open source, open state, open entry, open exit, and my favorite, open innovation. We want anybody to write this code. Okay, so how is this going to work? We don't have answers. So we are not ready for prime time. We are working to solve all these problems, and the more we make progress on the fundamental philosophical tension. Another one, some of our friends here talk about sovereignty. Sovereignty is a tension with composability. So if you're sovereign, you're not composable. Again, a fundamental philosophical trade-off. There's a lot of fundamental problems. We need several years to solve all of these. And as we solve them, before we solve them, we're not ready for prime time, right? There's privacy versus transparency. If you put everything on a blockchain, I take Grab or Uber or something and put everything on a blockchain, now it's transparent to the competitor what's the right economy that's going on all these chains. Is that something they want? I don't think so. So privacy versus transparency. So we have many fundamental problems in the space. I'm listing these out because, it's people like you who are going to solve this. So, we need to all work together to solve these problems. And it's better to be cognizant of the issues that exist rather than, rah, we're all great kind of an approach.
So, the thing is that blockchain infrastructure thrives on dilemma and trilemmas. So I think you've mentioned a bunch of dilemmas or trilemmas. But whatever it is, we always manage to get out of those dilemmas. And actually one pretty proven solution is kind of a client adaptivity, which is different people can take different points on that trade-off simultaneously. So you don't have to force everybody to be on the same point. So that may be one way out.
Like how David quotes it in, professors speak, but I mean, it's pretty clear.
I don't know if it's a compliment or not. I'll take it as a compliment. Thank you.
It's a compliment.
I definitely don't have the answer of how we get broader developer and user adoption, but I will say, I've been working on blockchain infrastructure for over 5 years now, and I feel I was totally captivated and mind blown when I read the Laserletter white paper, because I realized that for the first time there was actually a solution to the most pressing problems at the base layer in terms of scalability and flexibility, and we're finally now launching those products. We have rollups now. We're about to have more data availability layers launching that are going to unlock a new era in what is possible to do on chain. And I think that's at least, we're removing at least one of the blockers. There probably are other ones, developer experience. But we're also seeing things like, I'm kind of excited by Friend Tech, because I liked Olaf from Polychain tweeted that Friend Tech is built, almost all the infrastructure that's built on is less than a year old. And I think that kind of goes to show how better infrastructure and user experience tools, and wallets and things like that are actually making it now possible to build very compelling applications. And like things can go viral very quickly. And I think that's also why like there's a common thing of like, oh, there was too much infrastructure, or why do we need all this block space? Like why should Celestia have, 128 megabyte blocks? Like who's gonna buy that or whatever, right? And the reality is, sure, there might not be demand right now, but overnight, an app like Ventec could blow up. And if we don't have the infrastructure ready, then it's all going to fail again, right? And so we need to skate to where the puck is going, not where it is today. And I think we're super close to the application era. I'm really excited for when that takes off. Like that's what we've all been building for, The
iPhone moment.
Yes.
Let's turn that into a call to action, and then we'll just do a quick round and wrap up. Yeah. So based on everything you just said, Nick, what is your call to action to devs or builders today?
I mean, there's so many ways to contribute, right? Obviously, there's still lots of infrastructure problems to solve. I think there's a lot of the application layer. People need to start I think something that's important is. I think we need to blur the line between an application layer developer and a protocol level developer. I think to build the most compelling applications, you're going to need to know a lot more about the stack. You can't just limit yourself to smart contracts. I just think there's a lot of alpha and benefit to going a little bit deeper, and that's how you can really harness all the new tools that people like us that are building. So that's my call to action. I'm curious if people have anything else.
Yeah, no, I mean, sure, application devs, if they know a bit of the protocol, that makes sense. I mean, if you look I especially like the Spotify story where, they had to optimize the lower level to, reach I think 20 milliseconds or 200 milliseconds, they modified the communication protocol. They use UDP instead of TCP IP, for example, right? So, I mean, certainly it's good for application devs to know protocol development, but the reality is that application developers really just want to build great apps, and there has to be a separate category of developers who need to build this robust developer tooling, and of course they need to know how the base layer works, for example, and take advantage of these newer capabilities and build superior abstractions. So. In general, call to action, if you ask me, of course, all of this, but people should pay very close attention to the non-EVM, ZK-VM space. I would say there's a lot of high quality, stuff being built there. So the ZK EVM wave, has basically progressed, but the ZK VM thing, there's a lot of interesting things happening, and we see a lot of development in things like app rollups with custom state transition functions and custom state, right? Very lightweight rollups that eventually we hope will replace deploying a smart contract. You can replace that with app rollup. The tooling is not there yet. I mean, it'll take a little bit more time, but if you wanted some call to action from me, please, if those of you are interested, please, follow these ZK VMs. There are a lot.
Any names to drop?
Risk Zero, Maiden, even Mina, Cairo itself, for example, and there's a bunch of others. Fluent, Delphinus is building a ZK WASM, and so on, right? Just basically look at that, see what Cosmos wanted to do, and see if you can replicate it in in a ZK context, for example. I mean, if one single thing I want to do, I would encourage people to do this.
All right. Call to action. So often people tell me, hey, why are you doing BTC staking? Because, I launched my token. The only value of my token is actually staking. So if you have BTC staking, then what's the value of my token? So I said, well, staking, security is the means, not the end. And we're providing a cheaper means so that you can focus on the ends, which is the application.
From our viewpoint, I think two things that that can be fun to do. If you have any ideas for any distributed system that you want to build, be it a data storage network, an Oracle, a bridge, AI inference, you want to write a peer-to-peer chat application, anything, you can build it on EigenLayer. So, we're putting up a lot more information on how you can build arbitrary new code. This does not have to be in EVM. You can write in whatever language you want. That's one thing. The other thing is, like several of my friends here, we are also building a data availability system, EigenDA, which it gives you so much of data bandwidth, we don't know what to do with it, and is much higher than the total bandwidth today going on in the entire blockchain space. So if you have ideas for what might be like great applications, you should start exploring these new systems, and it's getting ready. It's in a year it'll be so ready that you can do a lot of things with these systems.
Right. Thank you everyone here for sharing, and everyone else, thank you for listening and tuning in.